a conductivity probe. What you're going to be doing is you're going to be testing the conductivity of a certain number of standards. With this one, you have to use proper laboratory procedure, please. So, yeah, I mean, heaven forbid.
Where's your manual?
I'm getting there. Yeah, thank you, actually. This one, believe it or not, here's the manual. Thank you.
It's a textbook.
This is the cheat sheet that you use to
The quick
do most of
reference
the
guide.
calibration here. Yeah, this one's very simple to calibrate. It's an ABB. It's simple, and same with the other turbidity, but the level is, or the pH is just incredibly difficult. Anyways, yeah. So you're going to be measuring some standards. The standards are down here. At the beginning of the lab, I'm going to pour in, let's say 1,000 microsiemens or 100 microsiemens or 1430, 13, for whatever reason is a standard. You're going to calibrate this, and it's just so incredibly simple, like I said. There's a bunch of numbers, and then they say what they are. So menu, it says calibrate. So you can say select, and then it will run you through which standards it wants you to put in there. I'm going to just go back to measure. There's a fault on this one. Don't worry about it too much. What that fault is it wants to see a high impedance measuring device coming from its output. So what I just said was wah, 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 wah. High impedance means a super high resistance coming off. So the 4 to 20 milliamp signal coming from here to your SCADA system or PLC is being simulated by this cheap little meter. And it doesn't like that. It wants a proper PLC. So don't worry about that. What are proper laboratory procedures? Well, take a nice clean beaker. If it's not clean, wash it. Pour a bit of the standard in. So I'm going to pour 1,000. This is just salt water. Salt water solution. Oh, try not to fill this up too much. These standards are actually fairly expensive. Now this probe has to be totally covered, and okay, we're just going to have it stabilized. Do it 800. That's not good. But watch what happens if I put this right to the bottom here. See it drop like crazy, or even close to the bottom, or to the sides. Gives you a false reading. You have to have about, the book says an inch. So for us, 2.5 centimeters, these are metric, around the probe. Yeah, that 1,000 is way off. It's probably an old standard. I'm going to have to, it either needs calibration or a new standard. But you're going to measure that, then you can measure it with this little Oaktron conductivity meter. And with this one, I'm getting same. What do I have with the other one?
Just a 740.
Well, this one's 800 and something, 860. I just need calibration. And I may have you do it with this instrument as well. So you'll be calibrating and testing with both the instruments. When you finish, please rinse off each probe, right, including this one. We'll take a proper file, rinse it off. And why do we do that?
So we don't leave salt behind.
Yeah. Otherwise, you'll, and then dispose of, when you're done, dispose of your conductivity and wash this out. Otherwise, you're going to have salt crystals forming. You can sort of see, when it evaporates, or you'll be messing it up. Then what you're going to do is just take some distilled water. Proper RO, distilled water, which that is not. And And you're going to take a little bit of salt. So probably no more than 1 ml at a time. Like the teeniest pinch of salt. And drop it in here and see what happens to your conductivity. And as you can see, it's climbing very rapidly. And that was just with a little tiny pinch. So that's conductivity. Use quite a, well, not a huge, not as big as turbidity or pH or level or flow, but still used in water treatment. Any questions on this one? It's much more fun doing the labs than sitting watching.